LabSocket-Embedded, also called LabSocket-E, is a new version of LabSocket that enables browser-based access to VIs operating on National Instruments real-time controllers, including CompactRIO, single-board RIO, myRIO, and PXI controllers. This video provides an introduction to the system. Let's start with a demonstration of LabSocket-E. Here we have a target VI that's running on this CompactRIO 9068 in interactive mode. The VI is acquiring data from this thermocouple on the CompactRIO and plotting the temperature in these two waveform graphs. Before starting this VI, I used the LabSocket-E client code generator tool, which I'll talk about more in a moment, to create the browser client code and to deploy that code to a directory served by the web server on the 9068. When we point a browser to the URL for the client code on the CompactRIO, the front panel elements are rendered in the browser. The LabSocket-E synchronizer, running in parallel to the target VI on the CompactRIO, maintains synchronization between each element on the front panel and its counterpart in the browser. There's no requirement for installation of a runtime engine or browser plugin on the client side, so any modern browser can be used to access the application on the real-time controller. For example, here we can see the temperature data being plotted in this iPhone browser. I'll touch the thermocouple again so you can see the temperature response on the iPhone. The other pages in the tab element of this demo VI illustrate the front panel elements that are supported by LabSocket-E. Here we have a set of controls and indicators that are wired to each other. Notice how LabSocket-E maintains synchronization between the VI front panel and the browser as the control elements in the browser are changed. XY graph support is demonstrated on this page. LabSocket-E supports sliders as controls and indicators, as shown here, as well as multi-column list boxes as controls and indicators, and picture rings as controls and indicators. This page demonstrates a technique for controlling the background color of string controls and indicators. I should mention that although in this demonstration the CompactRIO has been operating in interactive mode, LabSocket-E may also be used with controllers operating in headless mode. Now let's look at how LabSocket-E works. This schematic shows how LabSocket-E is used in the development process of a real-time application. The client code generator tool is used by the developer to automatically create the browser client in the form of HTML and JavaScript code based on the elements on the target VI front panel. The developer then uses this tool to deploy the browser client code to a directory within the web server root directory on the real-time platform. The other key component of the system is the synchronizer, which runs in parallel to the target VI and is responsible for continuously matching the values of the controls and indicators on the target VI front panel with those in the browser. The synchronizer is incorporated into the application by placing the LabSocket-E start VI on the block diagram of the target VI. This causes the synchronizer to become a dependency of the target VI, and it is therefore automatically deployed to the real-time platform during the target VI deployment process. During normal operation of the system, when the client code is loaded in a browser, the front panel elements are rendered and the browser sets up a WebSocket interface to the synchronizer. The synchronizer then continuously matches the values of the front panel controls and indicators with those in the browser. One detail that's worth noting is that there are no intermediary software components in the LabSocket-E architecture. The system uses the web server on the real-time platform, and the synchronizer also resides on the real-time platform. This arrangement makes the setup and configuration of the system very simple. LabSocket-E has been tested on a range of National Instruments real-time controllers. As shown in our demo, LabSocket-E is compatible with the CompactRIO 9068. It's also been tested with the CompactRIO 9030, 9074, 9012, a PXI 8110, a single-board RIO 9606, and more. A list of all of the controllers that have been proven to work with LabSocket-E as of January 2017 is presented here. This table shows that LabSocket-E works with controllers having disparate performance levels and that it's compatible with each of the operating systems available for real-time controllers. LabSocket-E is available now through VI Package Manager and is expected to be listed on the LabVIEW Tools Network website in early February 2017. For more information about LabSocket-E, please visit labsocket.com.